In this video, we will be learning about the Cartesian coordinate system, understanding the different parts of the coordinate system, and being able to plot points on it. In the last lesson, we learned how to identify points on a flat, two-dimensional plane. So a flat, two-dimensional space, and we learned multiple ways to do it, and that generally it is needed to have two parameters in order to fix that one point. So in this lesson, we will be diving into part 1 of Introduction to the Cartesian Coordinate System. There will be a part 2 that comes after this, so stay tuned for that. So your learning goals for today is to understand the Cartesian coordinate system and the horizontal axis, vertical axis, origin, and other basic concepts. And our second goal is, in a given Cartesian coordinate system, the position of a point can be plotted from its x and y values. So learning how to plot points, basically, on the coordinate system. So here's your introduction. In a plane, there are two main ways to determine the position of an object. So first, we have the azimuth and the distance, which is really the angle and the distance. We also have horizontal and vertical values. So which one can be written in the form of A, B? So to determine the position of the object in a plane, how many pieces of data is required? And we can fill that blank with 2. Remember, it's two-dimensional. That's why. So a plane, you have to remember, is two-dimensional. That's why it's so important that we have to understand that 2 pieces of data is required to plot a point. So how would you get A followed by B, though, on a Cartesian coordinate plane? So let's look at the coordinate plane, the coordinate system, the Cartesian coordinate system. Think, as shown, what are the numbers that points in A and B each represent? Which point represents 4? Well, we see this is a number line. So we have 0, on its left side we have -1, -2, -3, and on the right side we have 1, 2, 3, and 4. So you probably know all the basic stuff of a proper valid number line. First of all, it has to have equal unit lengths in between, and the values have to correspond. And generally you need to have 2 arrows on the sides, and that the positive side is always on the right side, and it is a straight line, not a line segment, but a line. So here let's look at point A. What does that represent? Well, point A is on the mark that represents -3. So A represents -3. B, following the same pattern, we have B equals 2. Represents 2, not equals 2. And which point represents 4? Well, we can move our cursor to number 4 and look at the point over there, and that would be C. And the point representing 4 would be point C. Think. From think 1, what is the relationship between the actual real numbers and the points on the number line? Well, as you can see, every single mark that represents a real number will have a point on it, and whether that point was named here or not, there will be a point on that. So the correspondence between a point on that number line and the real number that it represents is 1-to-1. So it has a 1-to-1 correspondence. Each point on the number line corresponds to a real number. This real number is called the coordinate of this point on the number line. And conversely, knowing a number, the position of the number on the number line can be determined. So find, we have north and west, and we have Great Road and Main Road. Carmen and Kaylee made an appointment to study in the library on the weekend. Carmen told Kaylee that the library was located 50 meters west of the northern section of Great Road and 30 meters north of the western part of Main Road. So what it's saying is that, the library, where is it? It's 50 meters west of the northern section of Great Road. So that would be, we have the northern section here. So that would be this section. And we have the western part. So that would be this part here. So 30 meters north, say this is 30 meters north, but it has to be the same time 50 meters west. So this is 50 meters west. So that way, as you can see, we can totally see the we can totally see what he is talking about by the location of the library, because we have it, we know what, we have 2 parameters here. So can Kaylee locate the location of the library from the map on the left according to Commons descriptions? So we can, right? Because so if we only had 1 parameter, say 50 meters west of the northern section, it could be anywhere here. That's 50 meters. But we need to know a place to stop, and that is also exactly 30 meters north of Main Road. How did Common describe the location of the library? Well, as you can see, here he gave 2 parameters. That's what we've been stressing about lately. We've been really emphasizing that. So that's how he described it. He described it using different directions, east, west, north and south. They're also perpendicular to each other, so that's good. And there were specific distances from those directions. Could Common have left out the words west and north? Well, could he have left them out? Well, let's cross them out and see if that would work or not. So cross out north and west. 50 meters of northern section and 30 meters of the western part of Main Road. We couldn't have done that because 50 meters from the Great Road. Well, could it be here? Could it be here? Could it be even here? We don't know that. So that's why we have to have that direction in. If Common said that the library is west of Great Road and north of Main Road, could you have located it? No, we couldn't. That's what we just tried. If Common only said 50 meters west of Great Road or only 30 meters north of Main Road, could you have located it? And we've already discussed that. The answer is no, because say 50 meters west of Great Road. That could be any point here, 50 meters west of Great Road. 30 meters north of Main Road, well, that could be anywhere here, 30 meters north. So you need a point, not a range of possibilities. So here we can have it represented on a number, on a coordinate plane. And as you can see, this is a plane, first of all, because it's 2D, we can represent it as a 2D surface. And it's a coordinate plane because you can plot coordinates on it. If Great Road and Main Road are viewed as 2 mutually perpendicular number axes, with their intersection as their common origin, thus forming a plane rectangular coordinate system. So that's the origin. So this, we want it to be 50 meters west of Great Road. So we draw a line. And this line is not just any line through this negative 50 here. It's a line that is perpendicular to this x-axis. You see the letter X labeling this horizontal axis because X represents the horizontal axis. The y-axis is the same as the vertical axis. So this line we just drew is perpendicular to the x-axis. At the same time, it is parallel to the y-axis. So this gives us our first coordinate, negative 50. Our second coordinate, remember that A followed by B, would be drawing a perpendicular line through positive 30 on the y-axis that is parallel to the x-axis but perpendicular to the y-axis. And that crosses to 30. So 30 would be our y-coordinate, which is our second coordinate in this coordinate group, in this pair. So 2 perpendicular axes are drawn on a plane to form the plane rectangular coordinate system. Like this, we have 2 axes drawn across each other, and this is a 90-degree angle. The vertical is called the y-axis, and the higher is greater in positive. So if we decrease, you know that the value is decreasing. If you increase, then the value is increasing, getting bigger. That's the vertical. The x-axis, which would be the horizontal axis, becomes greater, more positive to the right. So this is sort of like a number line. You can think of it as 2 number lines intersecting each other at their origin point, which is 0. The intersection of the x-axis and the y-axis is called the origin of the Cartesian coordinate system. And the origin is likely always the 0. You could change it sometimes, but the common value for it would be 0. So here this is not shown, but 1 greater than -1, that's 0, and 1 less than 1, that's 0. So this is their intersection point, that is 0. So on this Cartesian coordinate system, how would you represent point P? A perpendicular line towards the x-axis shows that the x-coordinate is -2. So this is the x-axis, right? And we have a perpendicular line towards it, forming the point M. A perpendicular line towards the y-axis shows the y-coordinate is 3. So we have point N over here at the intersection. We draw a perpendicular line towards the y-axis, and we land on number 3. Therefore, since we know its x-coordinate and y-coordinate, we can also find its coordinate pair. So if we put it in the form x followed by y, it would be p -2, 3. So here we know that this is the x-axis followed by the y-axis. The x-axis, the x-coordinate always comes first, all right? And p, that is the name of the point, so that's why it is outside these parentheses. The coordinates of point P is -2, 3. Okay, so here we have another Cartesian coordinate system, and here I'm just gonna trace this with white just in case you can't see. Okay, so try. Let me see the question. How would you find the coordinate points of A? Well, A, oopsie, see? Okay, so first we can draw a perpendicular line from point A to the x-axis. Okay, and this perpendicular line, since it's perpendicular to x, means it's parallel to y. So we draw that line, and we land on 4. So therefore the x-coordinate of A is 4. We do the same to the y-axis, and we follow on 3, meaning that its y-coordinate is 3. So if we put those together, we get the coordinate pair 4 by 3. Creating a perpendicular line from point A to the x-axis, we fall on the value 4. Therefore, the x-coordinate is 4. All right, second step, creating a perpendicular line from point A to y-axis, we fall on 3. Therefore, the y-coordinate is 3. So the coordinates of A is 4, 3. Find a point on the Cartesian coordinate system. 3 followed by -2. And this here is 3. So this is sort of the same steps but reversed. We can first draw a line, since right here 3 is the x value and -2 is the y value. Let's look at let's create a line where its x value is 3. That would be about here, right? All along this line would it have an x value of 3. What about -2 though? What other line will have a y value of -2? Well, that would be all along this line right here. And the place where they intersect would be the single and only point on this entire plane that matches the requirements. Both it has an x value of 3 and a y value of -2. It is the intersection point and the only intersection point of these two lines. So therefore, this is point A. All right, so let me erase my ink on the slide, and we see that this intersection here is point A. So how can we locate a point using coordinates? First, we can find the x and y coordinates, and then we can draw perpendicular lines at each of these two coordinates. The point where the lines intersect is the point we're looking for. So just to review, we draw a perpendicular line through point to the x-axis and the y-axis where they intersect. That's our point. So let's do one more example. Write the coordinates of each vertex of the polygon A, B, C, D, E, F in the figure below. So pause the video and write these down on a, say, sheet of paper, on a notepad by yourself, and then you can unpause the video and we will go over the answers. All right, nice. Let's see what you came up with. So we have 6 points. Number A would be -2 by 0. It has a x value of -2, but it's right on that x-axis. So this might confuse some beginners. This is just meaning that it has a y value of 0. Why? Because here you know how this is the origin? Well, this also has a value of 0. So this is why you could just think of that as 0. And it's on both the axes y and x. B is 0, -3. So it has an x value of 0. This, as you can see, 0 is the first number, meaning that this is the x value now. So we have x followed by y. All right? So 0 is the x value, -3 is the y value. Here, C has so now this is not just in the positive section or top section, we're also going down. So here it has a positive x value, so that's 3, and a negative y value, that's -3. So on. 4, 0, 3, 3, 0, 3. If you got all of these correct, congratulations. If you got some of them wrong, you should probably go back and check where you got it wrong. So, plot the following points on the Cartesian coordinate plane. Okay, here, especially when dealing with coordinate plane stuff or algebra or just geometry, and you have to use a coordinate plane, I highly suggest and recommend you use a piece of graph paper. You can get actual graph paper, or even if you have like maybe a laptop, a touchscreen laptop, or a let's say iPad nearby, you can say go into the whiteboard, turn on graph paper mode, and that would be really great for creating coordinate planes. Okay, so that's just my little tip to you. So point A, we can draw perpendicular lines, from each of these axes. It should be like a routine now. And B is here, C is here, D is here. Now the points where these two perpendicular lines intersect, that is the point we're looking for. So here are our coordinate characteristics. In the Cartesian coordinate system, two coordinate axes, that is the horizontal axis and the vertical axis, the x and y axes, divide the plane into 4 regions. Quadrants 1, 2, 3, and 4 as shown in the figure. So here we have 1, 2, 3, and 4. So remember these. It's not 1, 2, 3, 4. It's not 1, 2, 3, 4. This is the pattern we're going in. This counterclockwise rotation. So 1, 2, 3, 4. So these regions are referred to as quadrants. Quad, you have like, quad means 4, and this is divided into 4 equal regions. This is why they're called quadrants. Notice that points on the axes do not belong to any quadrant. Without looking at the Cartesian coordinate system, can you quickly tell where -5, 0, 0, -5, 3, 0, 0, 3, 0, 0 are located? What is your method? So -5, 0, that would be in quadrant. You might need a little bit of thinking. That would be on the negative half of the x-axis. Why? Because it has a y value of 0 and a negative x value. 0, -5, that is on the y-axis, for it has an x value of 0 and it has a negative y value. So are the follows. 0, 0 would be the origin point, because that's a special point. 0, 0, it's on both axes and it's not in neither quadrant. So here's a position. If you're in quadrant 1, all of these points will have a positive x coordinate and a positive y coordinate. Quadrant 2 will have a negative x coordinate and a positive y coordinate. So this is just a nice chart for you to memorize. You don't even have to memorize it, actually. This is just a basic pattern that you should know. Really, the important part of here is just knowing which quadrants are which ones, because you might get confused with that. And another little tip. If you're on a test and you write quadrant 1, try not to write it using Arabic numerals, which is 1, 2, 3, 4, these numerals that we use right now in modern times. because sometimes maybe your depends on your teacher, who your teacher is, but maybe your curriculum really emphasizes you to write the Roman numerals. So if that is the case, you should ask your teacher and try to write the Roman numerals for these answers. So without looking at the Cartesian coordinate system, can you now identify the quadrants that each of the points A, B, C, D, and E belong to, and explain how? Well, I'm just going to leave this activity to yourself because all you have to do is really refer to this chart, right? For example, A, it has a positive X and Y coordinate, and that means that it belongs in 1. Remember, if it has a coordinate of 0, it's not in either quadrant. It's either on the axis or on the origin point. 0 is neither negative nor positive. Observe the coordinate system and follow the characteristics of the points of the coordinates of the points on the coordinate axes. So what if it's on the positive side of the x-axis? It will have a positive x coordinate and a 0 for the y coordinate. This would be negative for the x-axis, 0. The same pattern you might guess is, see it says positive negative, that means that here this is positive negative, and since now this is on the y-axis, the x coordinates would be 0. So this is a pattern that you might have noticed. Without looking, can you quickly tell where the following 5 points are located and what is your method? Well, those are the points that we just looked at earlier, and 0, 0 is that center point. What is the relationship between points in the coordinate plane in ordered pairs, which are coordinates? Points on a number line have a 1-to-1 correspondence with real numbers. For any point on the coordinate plane, there is a unique pair of ordered real numbers, x, y, the coordinates of that point corresponding to it. Conversely, for any pair of ordered real numbers, there is a unique point that is a point with the coordinates x, y corresponding to it in the coordinate plane. So on the number line, right, since that's one-dimensional, you have a 1-to-1 correspondence between real numbers and the points that represent them. But on a coordinate plane, since now we're looking at a 2D surface, working with a 2D surface is different because you have another dimension to think about. That's why you have a pair of numbers. And that pair of numbers always have a point on the coordinate plane that matches it. So it could be any real numbers. So it could be, it could be a rational, it could be a fraction, it could be a decimal, it could be pi, things like that. Okay, so those, we've only been working with whole integers lately, but those are also real numbers and they also work. So in mathematics, it's very important that you have precise vocabulary, such as real numbers. Example 2. In the Cartesian coordinate system, trace the following points and indicate which quadrant they are in. A, B, C, and D. A would be here. Okay, so this is the answer key. As shown in the figure, first find the point representing 5 on the x-axis and then find the point representing 4 on the y-axis. Pass these 2 points as the vertical lines of the x-axis and y-axis, and the intersection of the 2 lines is point A. So you keep drawing perpendicular lines out, as we learned earlier on in this video. Their intersection points would be A, B, C, and D. So I'm just going to walk you through quickly example 3. Let the point M, A, B, so M is the name of that point and A, B are its ordered pair, on the coordinate system. When A is greater than 0 and B is less than 0, what quadrant is M in? Well, that would mean that A is positive and B is negative. So that means point M will have to be in the 4th quadrant if you remember the patterns we discovered earlier. For number 2, when AB, which means that when they're multiplied, which quadrant is M in? And now sometimes when, again in middle school, they won't just have what is 5 times 9? 45. Like, that's a one-answered question. Those are elementary school type of questions. In middle school and high school, you're going to have to really classify your answers and you got to discuss them separately. Okay? So there's 2 different possibilities for this. You have to have if and then logistics. So it can be in the 1st quadrant when A is greater than 0 and B is greater than 0, or in the 3rd quadrant when A is less than 0 and so is B. And for number 3, when A is any real number and B is less than 0, what quadrant is M in? Okay, so it says a is any real number, meaning that it could be 0. So it can be in the third quadrant when a is less than 0 and b is less than 0, or in the fourth quadrant when a is greater than 0 but b is still less than 0. And it can even be on the negative half of the y-axis when a is equal to 0 and b is less than 0. So always when you're discussing them separately, try to write down every single possible answer, all right? Even if it's not that, it's only one value, that still works. 0 is a very special value, and sometimes it really tricks students on exam tests, so you should really pay attention to that. In the Cartesian coordinate system, the point P with the coordinates m and m minus 2 is in the first quadrant. Then the value range of m is. Let's analyze. Any point in quadrant 1 has a positive x and has positive x and y coordinates. So if m is positive and m minus 2 is greater than 0, we can write out these equations. Solved, m is greater than 2. So here's a conclusion. The method of finding the value range of variables in the coordinates of a point. According to the symbolic features of the coordinates and points in each quadrant, list the inequalities or inequality groups about variables, and solve the inequality or inequality group to find the value range of the variable. Class summary. Today we learned all about the Cartesian coordinate system. So we learned about the different vocabulary in it, the origin and the axes, the coordinates of the plane, and that was split into definition and symbolic features as well as locating points. We also learned how to create an appropriate coordinate system, what makes it valid. Again, the two things we learned from this lesson that I want you to take away is to understand the Cartesian coordinate system in the horizontal axis, vertical axis, origin, and other basic concepts, as well as being able to plot a point out of its x and y values on the Cartesian coordinate system. Now, thank you for watching through Inquisitive Kids, and I'll see you in part 2 of this lesson.